Good morning, everybody. This is Scott Steinler again with Wastewater Technologies. For those of you that didn't join us last week, I am the Western Regional Manager for Blucher Piping and Drainage Systems. So that's me. We can be reached at blucherpipe.com. And again, my name is Scott Steinler, Western Regional Manager. If you wish to have more information on this topic or any other topic that I'm going to talk about at the end of this presentation, please be sure to leave your email address in the comments below, or feel free to email me directly at scott.steinler@wattswater.com. Once again, that would be scott.steinler@wattswater.com. So today we wanted to have a little conversation about Blucher in the healthcare environment. So we'll get into that. So we like to think of buildings as a living, breathing environment. People have a real out of sight, out of mind approach when you start talking about your building infrastructure. People tend to focus more on the exposed surfaces, such as, countertops, architectural features, plumbing fixtures, even, wall coverings, floor coverings, things like that. But really what we're starting to figure out, particularly in today's market, is that there's a lot more concern that should be paid to what's actually going on above the ceiling and in the flooring systems, or even in the walls. Want to thank our friends over at South Coast Engineering Group. That's Peter Kraut and his group for giving us this lovely picture of the HVAC system inside Arrowhead Regional Medical Center. We appreciate them contributing that. Thought I'd give you guys a few props while I'm doing this. So let's talk a little bit more about actually Blucher in the healthcare environment, and start with a video that we've downloaded from the Centers for Disease Control and Prevention on hospital-acquired infections.
On any given day, about 1 in 25 hospital patients have an infection caused by their medical care. Almost half of these patients are 65 or older. There are 5 places where patients are most likely to get infections: in the bloodstream, the urinary tract, the gut, and the 2 most common places are the site of surgery and the lungs. The germs most likely to cause healthcare-associated infections include C. difficile, or deadly diarrhea, staph, including the drug-resistant type known as MRSA, a family of germs known as Enterobacteriaceae that includes CRE, the nightmare bacteria, Enterococcus, which can be resistant to an important antibiotic, vancomycin, and Pseudomonas, which can cause infections of the lungs and bloodstream. 1 in every 9 patients who gets an infection will die during their hospitalization. Over the last several years, great progress has been made in preventing some infections. For example, bloodstream infections in patients with central lines have been nearly cut in half in the last 5 years. But more work needs to be done. CDC's goal is to eliminate all healthcare-associated infections. We work 24/7 to save lives and protect people.
Thank you. Hope you enjoyed that video. It's full of absolutely incredible information. So one of the things we've been doing is trying to kind of find a use of our time. So if you've been like me, and of course you are if you live anywhere in civilized America, you've been on the quarantine. So we've been stuck at home, and it's given us a lot of time to start digging in and doing a little bit of research. One of the things that I've always asked myself, particularly when I came to work for Blucher, is why do we use stainless steel? What's the advantages of one piping system over another? And is it actually worth the price? Well, again, doing research, I originally started out with like the food and beverage market, and now started getting into a little bit more focus on the healthcare industry. And the numbers are absolutely astonishing. So all the latest figures we found is that in 2015, $1.09 billion was allocated just towards the settlement, legal fees, and direct costs associated with healthcare-acquired infections. Now, this can include anything from Legionella to enterobacteria or surgical site infection, anything along those lines. If you take that number and you put today's inflation rate, that number actually turns out to be closer to $160 billion. And the thing, we talk about billions of dollars, and it's very hard for the human mind to actually comprehend exactly how much money we're talking about here. So in order to kind of wrap my own head around it, what I figured is, like, I took the average length of a dollar bill, or the length of a dollar bill laid end to end, and calculated that it would wrap around the equator of the earth 652 times in order to come up with $160 billion. So it is just an absolutely astonishing number. Furthermore, when I looked at that number, I compared it to the GDP of every nation on earth. So $160 billion is basically the 57th nation's economy, their entire GDP. So out of 192 nations, our healthcare acquired infection costs are more than the GDP of, 140 nations. So it's an absolutely astonishing number that we're dealing with here. So what if I told you we could actually start to address that a little bit more? Well, that's what we're going to do. So one of the things we looked at again is disease transmission. How are these hospitals getting disease? How is disease moving from one room to the next? And I hated to kind of go in this direction, but one of the things that came up in my social media feed was the transmission of SARS. So we're not only talking about COVID-19, we're talking about the initial SARS outbreak of about 2000. I think it was about 2002, 2005. There was a SARS outbreak in China. And the way they figured that was transmitting and moving from room to room was through dried out traps. So that's what I'm showing you here. That virus in the top left, that is COVID-19. I'm sure you've seen that image. And the bottom picture on the right is a P-trap. So what the contention is that when the traps either siphon or the water evaporates out of the trap, then it provides a transmission pathway for the air to kind of get pushed into a room and carry with it that bacteria and or virus. Kind of affirming this, the Arizona State University and University of Arizona out of Tempe, what they are doing is starting to look at the waste streams. So we know that, again, I'm going to refer to the instances that we're having in today's times of the COVID-19 transmission. So there weren't enough blood tests going around. So a couple weeks ago, what ASU started doing was taking a look at the waste stream. It's very similar to the way that they were looking at the waste stream out of the northeast portion of the U.S. to kind of ascertain how bad the opiate problem was and how bad drug abuse was going on. So what they do is they sample that wastewater. They pull a sample out of it and they check for certain things. So in this case, they were looking for the presence of COVID-19 to kind of ascertain how bad the infection rate is and how many people really have it. So this is proof positive that anything that we have in our bodies that we put into the sanitary system is going to get transmitted from one location to another. And in healthcare, that could be absolutely disastrous. So how does that happen? There's a couple ways it can happen. Piping systems, particularly when you're talking about older piping systems in healthcare, they can get damaged through either microbiologically influenced corrosion or hydrogen sulfide corrosion. And that basically, if you're looking at this picture over here on the left, and I'm not sure if my mouse is actually showing up on the presentation, it probably is. But you can see that there's this strange erosion pattern, this crack in the vertical location on the piping system. And what that's telling us is that there's hydrogen sulfide condensation occurring higher up in the piping system. And when that occurs, it forms sulfuric acid, and that kind of forms a waterway down the piping system. And over time, it erodes the entire piping system out. And then that piping system will split open, and it provides a pathway for some sort of pathogen to go in and out, and or hydrogen sulfide gas, which in and of itself can be very dangerous. So how this occurs, and again, let's talk about a little bit more about biofilms. So biofilms are a naturally occurring thing, and biofilms are responsible for about 98% of all infections everywhere. So if you go in even into your own private shower and you start maybe scraping your fingernail across your floor drain or even the shower wall, it's got a little slimy feel to it. Well, that's biofilm. So biofilm, while it's inconvenient, not necessarily harmful. What it does, though, is it provides a hospitable environment for more aggressive pathogens to possibly attach themselves, and that's how they propagate in the piping systems. A good example of that, and I don't actually have this picture, and if you're interested in any of these topics and if you want more information, please feel free to reach out. I can talk about this stuff for about an hour and a half to 2 hours easily. and we can really get into more detail on any of these topics. But in that, what I was talking about with the biofilm is it actually grows in the piping system at a rate of about 5 centimeters per day. So, you know, you got some growth going on, and that'll go from trap to trap and make its way from one room to the next. And that's how these things are propagating. So if we were talking about Blucher stainless steel, particularly in the healthcare environment, what are the advantages of it? And we're looking for a material that helps to mitigate bacterial and virus propagation, reducing your risk of hospital-acquired infections. Obviously, stainless steel has always been the preferred material for kitchens, resistant to grease and the breakdown of organic matter. Laboratories, we can handle a lot of different chemicals. We talked about sanitary waste systems, vacuum systems. A little segue on the vacuum systems. My coworker Sam Bolt on the 13th of May, he's going to be giving us a little discussion about Blucher piping in the marine environment. And if you've ever been on a cruise ship or a large naval vessel, those are all vacuum systems. So that's Blucher's used in that as well. So we know that we want to put these where longevity and corrosion resistance are very important to you. And it can be used in plenum areas. We don't have to pass E84 or UL 723 because the material itself is non-combustible in nature. We also have dual containment piping configurations for you. The pipe itself is very, very quiet, so it has some really good acoustical properties to it. We use a push-fit jointing system. Everything's acid pickled in the factory, so you don't have these corrosion points or weld spots where you can have breakdown of the piping material. We do offer a lot of customized solutions to meet your particular needs. When you look at the install cost of a Blucher 3/16 stainless steel system, we find that we're really cost competitive with the more traditional, even cast iron or plastics. We do get some real strong advantages to using Blucher in that environment. We do provide superior protection and return on investment. I have a slide in my full presentation. I'd love to give that to you, but I quoted a very wise man who once said that Blucher is a perfect material for any position or any application where the owner has a vested interest in maintaining a problem-free facility. And I quoted a very wise man, and of course that would be me. So again, let's talk a little bit about that laboratory piping. We just have a basic list of some of the chemicals that we are compatible with. Some we do better than others, but I do have complete compatibility with a lot of materials, and I could take a look at your MSDS sheets or even any of your chemical lists to determine whether or not we're going to be suitable for your application. Talking about integration, if you do any healthcare design, you're familiar with the NIH design policy and guideline pamphlet or booklet. It's about yay thick. I'd love to print it. If you have an office that's open, let me know. I'd like to come print something. They are very, very particular in talking about the connection between the floor drain and the piping material. I did a job down in Louisiana where they are having a tremendous problem with that. And if you don't think that this is a major issue, it can be. So you need to be sure that your outlets on your drains and your piping systems are compatible, so you do get a tight seal and you don't end up with leakage. We talked a little bit about the fire resistance. Again, evacuating a hospital does take longer than a traditional commercial building. Talked about not having to qualify under ASTM E84 or UL 723, as we do not burn and we're not going to propagate fire for you. So a little bit more about our dual containment. So dual containment, if you have an operating room or an electrical room and you have absolutely no choice but to go over that space with a piping system, dual containment pipe and pipe is going to be your avenue to go with. NIH does frown upon drip pans or any other type of kind of safety precautions. Pipe and pipe is preferred methodology for doing that. Push fit versus a welded pipe, so you can get in and out quickly. If you're talking about a retrofit application, you don't want to have a lot of downtime. You can carry these sticks. They're very light. You go in, you push them together with a lubricant that does double as a hand sanitizer, we found out, so that was interesting. So if you do want to have that kind of application where you're in and out quickly, push fit versus welded definitely is going to be in your wheelhouse. Talked a little bit about the acid pickling and passivation. We submerge everything in a hydrofluoric and nitric acid solution, so all the weld seams are cleaned up. Makes for a very long-lasting system for you. So, with that, again, I would like to thank everybody for joining me again. Okay, apparently we do have a question coming in through Microsoft Teams, so I'm going to listen for a second and get that question. What do we got? So the question was, can drain lines carry viruses through the plumbing systems? Absolutely. A drain line can carry anything that you get into the human body through a plumbing system. So it internally has to come out somewhere. It does end up in the drainage system, and it does propagate. The key is keeping it in that system and not giving it an environment that it can continue to propagate and spread. Okay, well, apparently there's no other questions. I would like to thank everybody again for joining me. And as a reminder, if you'd like any other information on this, or if you'd like us to do some sort of webinar for you, we do offer CEUs. I have a non-branded version of this for you if you're with one of the ASPE groups or engineering groups and you're looking to obtain those continuing education units. We would ask that you could either email me directly or you could send a private message over to Wastewater Technologies through the link on the Facebook page. Please enter your email and we'll get back to you. And as a reminder, May 13th next week, Sam Bolt is going to give us a discussion on the marine environment and Blucher piping systems. It's going to be a great topic, very interesting, and Sam is an incredible presenter, so I'd encourage you to join us then. So if that's it, I'd like to thank everybody for joining me again, and I look forward to seeing you when everything's lifted. Take care.